Hey everyone, it's that Math Magician. On this video, we're going to take another look at the tree diagram and we'll see how it'll help us map out the sample space or the possible outcomes for a probability question. So let's go ahead and jump into our example situation here where I have a maze that a rat is going to be moving through, and notice that he'll be going into 3 different rooms. Our rat will either get to room A, into room B, or into room C. And we want to figure out what's the probability of him getting to those 3 rooms. Our rat's going to start in this corner here. He'll be moving down the maze, and every time he gets into a fork in the road where he has choices, we're going to say that he has an equal chance of going down each route. For example, when he's here, he'll have a 1 in 2 chance of either going up or going down. And every time he gets to that fork in the road, we want to make sure we're showing that there's an equal chance of him going there. And notice that there are lots of ways for him to end up going into these rooms. And it's going to be up to us to figure out what is the probability of him getting into room A, into room B, and into room C. I think what's going to be very helpful for us on this problem is that we should use a tree diagram. And I want to show how that's going to help us solve this problem here. Again, we're going to want to find the probability of getting to A, into B, and into room C. And I think we can show that with a tree diagram. So let's go ahead and map this out. I'm going to have the first position where our rat is. Notice that that first position is sort of this position right there. Right? When he gets to that spot there, he has 2 different routes to choose from. He can either go up or he can go the down route. And so I'm going to show that here by separating my tree diagram into 2 possible outcomes. Either he's going up or he's going down, remembering he has an equal chance of going down each route. So I'm going to write this as 1/2 and 1/2. So far, so good. Now let's say he went up first. Notice that as he went up, he's at another fork in the road where he has 3 different ways to choose from. I'm going to show that now on this part of my tree diagram right here by showing that there are 3 different ways for our rat to go. Notice that if he goes into the top room, he will end up in A. If he goes into the middle route, he'll still end up in room A. But if he takes that bottom route, he is now in the room B. And notice 3 different ways to go through it, each an equal chance for this rat to go down. That means our fraction for each branch here is going to be 1/3, 1 out of 3, and 1 out of 3. Perfect. Again, so far so good. We're doing good. Now, let's go ahead and follow the route where he went to the bottom. When he's down here at this bottom branch, he ends up at this point right here. And at this point, he has, again, 2 different outcomes to choose from. He can either go up or he can go down again. And once again, I want to just reiterate, every time he comes into the fork of the road, he has an equal chance of going down each route. So since there are 2 different ways for him to go, that means each of these is going to be represented with 1 out of 2. Perfect. Now let's say that he took that up route. He went up and now he's at this point of the maze. Notice that again he has 2 different ways to go again. He can either go up where he'll be in room B, or he can choose to go down where he'll end up in room C. That is exactly what we want to show. Awesome. And then let's just finish out this tree diagram with realizing that if he goes down, he's not going to end up at another fork in the road. He's actually going to get straight there into room C. That is our complete diagram of this problem here, where we have our rat going through this maze and we're showing every single point that he's going through. Now, some of you might have noticed already that our tree diagram matches the red lines that I initially drew out, because this problem, working through a maze, the maze there is actually your tree diagram. So really all I'm doing here is redrawing all the routes that our rat can take, but then also writing in the fractions. It's important that we write the fractions in to show each possible way he might be going. But now that I have that done, I can definitely figure out the probability that he ends up in room A, the probability that he ends up in room B, and the probability that he ends up in room C. Some of you might be thinking, oh, there's 6 possible outcomes. He gets to A 2 out of those 6. So the chance of him getting there is 2 out of 6. But we can't think like that. We have to go through the tree diagram, and we need to be multiplying all the fractions we work through as we maneuver through it. And let me show you what I mean. If I go this top route, notice that I'm going to be passing the 1/2 there and the 1/3 there. I need to take both of those fractions, 1/2 and 1/3, and multiply them. And 1/2 times 1/3 ends up being 1 out of 6. So the chance of him reaching that top room for room A is 1 out of 6. I think the other one is also going to be 1 out of 6 because it ends up being 1/2 times 1/3 again. And then for B as well, we're still passing by 1/2 and 1/3, so all of these end up being 1 out of 6. Now, here's where it's going to change for us. The rest of these are not out of 1 out of 6s. They actually are different because we're going to have to multiply different fractions. Let me show you what I mean. Let's go to the bottom route. Let's say he's going down to this bottom room C here. Notice that as he moves through there, he's going to pass that 1/2 and that other 1/2. So we have 1/2 times 1/2, which is going to give us 1 out of 4. So you see how it's changing based on the fractions that I'm going across. Now when we get to our final 2, this is going to be a little more trickier for us because as they get down to these other routes here, I'll go ahead and highlight it in another color. Notice that I'm passing by the 1/2, this 1/2, and a third 1/2. There are actually 3 fractions there that we have to multiply. But again, that's nothing that we can't do. What is 1/2 times 1/2 times 1/2? Well, let's slow it down a bit. 1/2 times 1/2 is 1/4, and 1/4 times another 1/2 would end up being 1 out of 8. I'll show that right here. 1/2 times 1/2 times 1/2. Remember, multiply the tops, multiply the bottoms. That other option there is also going to be 1 out of 8. There it is, our perfectly filled out tree diagram that now is going to allow us to answer the question that was originally posed to us. And that question was, what's the probability that the rat will end up in room A? What's the probability that he'll end up in room B? And what's the probability that he'll end up in room C? So let's go ahead and figure out all these possible outcomes using our tree diagram to help us through that. So, what's the probability of him getting to room A? Well, the only outcomes here that he gets to room A are both 1 out of 6. So we're going to take 1/6 plus 1/6. Remember, when you add fractions, you need them to have a common denominator. These guys do. They already both have a 6 down there. So we just now need to add the tops. And 1 plus 1 is going to give us 2. And 2 over 6 reduces to 1/3. So what's the chance of him getting into room A? He has a 1 in 3 chance getting into room A. Perfect. Let's go ahead now and move on to room B. Notice for room B, he's either going to have a 1 out of 6 chance for the first room, but then a 1 out of 8 chance into the second room. So we can't just add those together because they both have a 6 and an 8 in their denominator. We need that number to be the same. So before we can do that, we have to think about what number are we going to multiply each fraction by so that we get our common denominator. And I think our common denominator here for 6 and 8 is actually going to be 24 because 6 and 8 both go into 24. And for 6, I'd have to multiply that by 4, which means this problem is going to have a 4 on the top, that fraction. And then the other, 8 times, I believe, 3, is going to turn that into the 24. And what's 3 times 1? Well, 3 times 1 is just 3. So, I now have 4 over 24ths plus 3 over 24ths. That's going to equal 7 out of 24ths. So the chance of our rat getting into room B is 7 out of 24 possibilities. Notice that that problem needed a little more work because they were not the same denominator. But hopefully that's review for us at this point. Get your common denominator and then just add them up. Perfect. All right, our last room here is the probability that we get to room C. Well, I see that that is either going to be a 1 out of 8 chance or a 1 out of 4 chance. So we're going to take those two fractions and add them together. But again, notice, not the same denominator. But I think this one's going to be a little easier because 8 is okay. I think I just need to multiply the second fraction by 2 to get that common denominator. Because 1 over 8 is going to work out for us, but that 4 we need to change into an 8. So we'll multiply the top and the bottom by 2, and I think we end up with 2/8. So what's 1/8 plus 2/8? I think it's going to end up equaling 3 out of 8. There you go. That is a complete tree diagram showing us all the possible outcomes with every single fraction. Now we're able to solve the probability of each room. I just want to point out again, filling out the tree diagram is not the answer to this problem, but it helps us solve this problem. Without the tree diagram, we're not able to get all these fractions here to add. So it's very important that when you're filling out your tree diagram that you're taking your time, making sure every possible route is being shown so that you can answer the question correctly. It's That Math Magician, and I'll see you on the next video.